Hey guys, I'm Archana from Edureka and I welcome you to this session on AWS Fargate, which is a compute engine for Amazon Elastic Container Service. But before we dig in, let's take a look at topics that we'll be discussing today. First, we'll discuss what is the need for AWS Fargate. Then we'll see what AWS Fargate actually is and how it works. Moving on, let's take a look at few key concepts that you must know when you're dealing with AWS Fargate. And finally, we'll be doing a demo in which we'll be deploying an application on AWS Elastic Container Service using Fargate launch time. I hope the agenda was clear to you guys, so let's get started. First, let's try to understand why Amazon launched AWS Fargate when it already has other popular container services like Amazon Elastic Container Service and Amazon ECS for Kubernetes. And what is the story behind it? So about few years ago, before any container services even introduced, people used to launch their applications on virtual machine. Well, in this case, it is Amazon EC2 instances. So they would create this application package. This application package had code, lot of system libraries, system tools, web frameworks, and many other software packages that are needed to run an application successfully. Then they would take this application package and combine it with operating system into what we call Amazon machine image. Then they would launch this Amazon machine image and run it on Amazon EC2 instance. This worked fairly well. Then the Docker came along and containers started to become very popular and people started deploying their applications on these containers. These containers, just like virtual machines, remove the need for physical hardware, they decrease the energy consumption and increase the effectiveness. But the question here is, how are these containers any different from virtual machines? Well, the main difference between them is their architecture. I won't go into much details here, but let me give you a basic idea. As you can see in the diagram, in the bottom layer, we have host machine or host operating system. This host machine provides different kind of resources like RAM and CPU for all virtual machines. And these resources are shared among different virtual machines. And then there is hypervisor. It sits between your host machine and guest operating system. You can think of this hypervisor as a piece of software or firmware or hardware that creates and runs different virtual machines. And then we have virtual machines sitting on top of hypervisor. As you can see in the diagram, each virtual machine has an underlying operating system, virtualized hardware, and the user space to work on. Now, when we're talking about container services, with containers, instead of virtualizing the entire operating system or the computer like we do in virtual machine, just the operating system is virtualized. Well, what I want to say is containers share the host system's operating system with other containers as well. This way, your application package is completely separated from an underlying operating system. And you can also get certain level of isolation between all your applications that are running on single operating system. When your application is separated from underlying operating system, you can easily maintain all your applications that are running on different containers but on same EC2 instance. And moreover, you can use your EC2 instances more efficiently as well. So this container service started becoming more and more popular and people started using them at very huge scale. So the number of containers in an instance started increasing and the number of instances also increased. Now, managing all this increased number of containers and instances is always a tedious task. This was when Amazon introduced a container management service called Elastic Container Management Service. This Amazon ECS removed the need for the users to manage all the EC2 instances and the containers. So with this Amazon Elastic Container Service, users no longer had to manage the containers and the clusters. This Amazon ECS service kept track of all the instances, the applications that are running on these instances. It also kept track of the number of resources that were used by containers and the number of resources that are still available. So basically, this container management service did everything for the users. But still, using this container management service removed only a part of overhead that users were dealing with. Users still had to configure and manage the underlying instances that form clusters, as in the users still had to manage the EC2 instances on which these clusters of containers were running. Now, if we take a peek into one of these instances, you can see that an instance has container, lot of containers, an entire operating system, a Docker daemon which acts as an interface between different containers in instance, and then you have EC2 agent and many other system level libraries and software packages. Now, managing the system level libraries, packages, lot of containers, an entire operating system for a single instance is a relatively easy task. But suppose if you have to do this for fleet of instances, then obviously it will become a difficult task. So all users wanted to do was to build their application, but they ended up managing containers and the underlying instances on which these containers were running. As a solution to this problem, Amazon introduced AWS Fargate. So with AWS Fargate, you no longer have to deal with EC2 instances. In fact, you don't have to use EC2 instances at all because AWS Fargate itself will act as a compute engine. So you only have to think about containers, so you can just focus on building and operating your application in a proper manner. And this AWS Fargate will launch your containers and host them for you and scale them as well. So AWS Fargate makes it easy to scale your applications. You don't have to worry if you have provided enough number of compute resources or storage resources for your application. You just have to specify your application requirements, and AWS Fargate will manage all the scaling and the infrastructure needs to run your application in a very highly available manner. And finally, AWS Fargate seamlessly integrates with Amazon Elastic Container Service and Amazon Elastic Container Service for Kubernetes. This way, with just few simple steps, you can launch containers on Amazon Elastic Container Service using AWS Fargate launch type. So there you go, guys. That was the story behind AWS Fargate. And now you know what was the need for AWS Fargate. So let me define AWS Fargate for you. AWS Fargate, in basic terms, is a compute engine that allows you to run containers without you having to provision, configure, or manage and scale clusters of virtual machines on which your containers run. Now let's dig a little deeper and see how this Fargate actually operates. So the image that you see on the screen will give you a rough idea of how actually AWS Fargate operates. Let's try to figure it out. So as you can see, as your first step, you built a container image. In this container image, you built in such a way that it's suitable for application. And then you store this container image in a registry. Well, you have Docker Hub, or you can use Amazon Elastic Container Registry. And from this registry, you can download the image whenever you want and run on the cluster. So now you have built a container image. The next step is you choose a container management service. It should be either Amazon Elastic Container Service or Amazon Elastic Container Service for Kubernetes. Once you've chosen a proper container orchestration service, you need to create a cluster so that you can store all the containers and the resources that you have assigned to your application. This is where you have to make a choice between choosing EC2 or Fargate. So obviously we'll be choosing Fargate here. So now you launch a container, and AWS Fargate runs your container and manages all the underlying infrastructures and clusters for you. Suppose later on, if your application needs extra resources, then AWS Fargate seamlessly scales your application without you having to bother about it. So wasn't that simple? Let's summarize what we've learned till now. So you built a container image that is suitable for your application. Then you choose a container management service out of ECS or ECS for Kubernetes. Then you launch a container using AWS Fargate launch type. And this AWS Fargate will manage and configure all the underlying infrastructure instances and the clusters for you. And suppose if your application needs extra compute or storage resources later on, it will seamlessly scale your application needs without you having to bother about it. So there you go, guys. That's how AWS Fargate works. And now let's take a look at a few key concepts that you should know when you're dealing with AWS Fargate. Okay, so first we have containers. I'm sure you might have heard of Docker containers, and I'm sure you know what those are. Well, a Docker container is a standardized unit of software development. In simple terms, it has everything you need to kickstart your application, like system libraries, code, system tools, runtime, and web frameworks, and many other things. Now, these containers are created on a read-only template, which we call container image. And these images are built from a Docker file. You can think of this Docker file as a plain text file that specifies all the components that you should include in your container. So once your Docker container image is created, it is stored in the container registry, like it is stored in the Docker Hub, or you can use Amazon Elastic Container Registry service. From there, you can download image whenever you want and run it on the cluster. So it's as simple as that. So you have a Docker file, which has all the specifications regarding your container. And from this Docker file, you create a container image and then store it in container registry. And from container registry, you download image whenever you want and run it on the cluster. And then we have task definition. Well, to prepare your application to run on Amazon ECS service, you need to create a task definition. You can think of this task definition as a blueprint for your application. So basically, it's a text file, mostly in JSON format, that describes one or more containers that you'll be using for your application. When I say it describes your containers, it includes the type of containers that you'll be using for your application, or the launch type which you'll be using, or the ports which should be open for your application to be accessed, among many other things. So the following is an example of a simple task definition that defines a single container that runs on Nginx web server, and it's using a Fargate launch type. So as you can see, the simple task definition belongs to web server family. And as for the container definition, you have name, image, and the memory and CPU requirements. And it also says that we are launching this container using Fargate launch type. Then you have task requirements as in network mode, memory, and CPU requirements. So don't worry about it, guys. We'll deal with it in the demo part of the session. You'll understand it much better over there. So just keep in mind that this task definition is like a blueprint for your application. So guys, next we have task. Well, let me give you an example. I'm sure when you're writing a program, you might have used class and objects. Like object is an instance of class. Similarly, a task is instantiation of task definition within a cluster. So once you've created a task definition for your application, you need to specify the number of tasks that will run on your cluster. Well, you can always go ahead and have single task, but it's always good to have more number of tasks. Suppose one of your tasks fails, then your other tasks will come into picture. Then you have Amazon ECS task scheduler. It's responsible for placing your task within your cluster. Well, there are several different kind of scheduling options available, but mostly you can go ahead and define a service that runs and maintains user-specified number of tasks simultaneously. We'll do that in the demo part of this session. I'll show you how many tasks you can add, where you can add, and how do you do it. And now, like I said, the task scheduler is responsible for placing these tasks within your cluster. But what is cluster? Well, it's logically a group of resources that you're assigning to your application. Suppose if you're using Fargate launch type within your cluster, then Amazon Elastic Container Service will manage all your cluster resources. But if you're using EC2 launch type, then all your cluster will be considered as a group of container instances which you will have to manage. So there you go, guys. Now you know what containers are and how container is actually created. Then you know what task definition is, a task keys, and clusters. Now we are ready enough to venture ahead and deploy an application on Elastic Container Service using Fargate launch type. So let's go ahead and do that. So guys, this is my AWS Management Console, and I hope you've understood what we've learned in the theory part of the session and you know all the key concepts. Now let's go ahead and deploy an application using AWS Fargate launch type. So first I'll have to select Elastic Container Service here. If you're using Elastic Container Service for the first time, you'll land on this page. And there's a get started option at the bottom of the page. When you click on that, it'll directly take you to a page where you can start using Fargate. But before we do that, let's go ahead and explore other features of Elastic Container Service, as in how to launch an application without using Fargate. Only then you'll understand the difference of Fargate and EC2. So there you go. Like I said earlier, creating or launching an application on Elastic Container Service basically has 3 steps. First, you need to go ahead and create an image for your container. That is what you will do in this Amazon ECR part. Then you need to create a task definition as in blueprint for your application. Finally, the cluster to hold your containers as well as the resources that you've assigned to your application. So click on this repository. Basically, a repository is where you store your Docker images and Amazon Elastic Container Registry. Click on this Get Started. Give your repository a unique name and the endpoint will be specified here. And click on Next Step. So let's say My Image and click on Next Step. Now your repository is ready. So like I said earlier, it's a place or it's a location where you store your image. Well, there are certain details specified here, how to create an image and push image to this repository. We won't be going into much details here, but let's see what is there. The first step is to log into your Docker, then build an image. Then this is command to push the image into the repository which you just created. So you just follow these steps on your command prompt and your image is created and will be pushed to repository which you just created. So let's go back. Okay, let's assume that we have created an image and we have pushed into our repository and our container image is now ready to use. And as for the next step, we need to create a task definition. Well, like I said earlier, it's like a blueprint for your application. So every time you launch a task in Amazon ECS, you specify task definition. This way, the service knows which Docker image to use, how many number of containers your application need, and the resources allocated to these containers. So you have this create new task definition here. Click on that. So you have 2 options where you specify, do you want to launch your application using Fargate or EC2? Let's select EC2 first. So click on Next Step here. First thing you do is configure task and container definitions. So give a unique name for your task definition. And it says that we've chosen to launch an application using EC2. In the task role, suppose you want your task to contact other AWS services, you can use this API role. Then as for the network mode, you can create your own VPC or you can use the default VPC as well. And now, earlier we created image and stored it in repository. Suppose you want to pull that image and use that in your cluster, then you need to create a role which gives you permission to do that. So that is what this task execution role does. And in addition to that, it also publishes your container logs to Amazon CloudWatch on your behalf. Well, you can go ahead and create one on your own, or you can just ask the Elastic Container Service to create a default one for you. If I say none, then no task execution role will be created. Well, I can use this already existing one or create a new one. Next, you need to configure task definition parameters like CPU units and the memory units that your task might require. Then there's an option which says add container. So this is where you add your container image that you created earlier. This is the image ID, give your container a name and click on add here. We won't be doing that here. I'm just showing you how it happens. That's it. And there are certain other details which I won't be going into. Then you click on create option here. So that's it. Now you know how to create an image, store it in repository, how to create a task definition and attach your containers to this task definition. Now finally, clusters. Okay, I forgot to create a task definition using Fargate launch type. So let me go back. So again, create new task definition and use Fargate launch type. Click on next step. Everything is same except here in case of EC2, it shows Fargate. As you can see, rest is same. You have task role, network mode, again, task execution role, task configuration details like CPU and memory and the container image. Okay, now let's go back. So now you have assigned all the resources that you need to your application. You have created a container and a task definition. The next thing you need is you to store all this task definition, containers, and all the resources in cluster. So you can always go ahead and click on get started option, which will directly take you to Fargate page, or you can just click on create cluster. Well, when you do that, it asks you to choose either Fargate type or EC2 types. Well, in EC2, you have two, EC2 Linux and EC2 Windows. Let's go ahead and choose one, EC2 Windows, and click on next step. Well, obviously, it'll ask for a unique cluster name. Give your cluster a name and choose what type of instance model you want to use, on-demand or spot. Then instant type, as like you know that there are different instance types, you can choose one of your choice out of the available ones. Well, the next is number of instances. Suppose you want all your containers to sit in one instance, then you can choose one. Suppose if you want to use fleet of instances, then you can specify the number you need there. Then the storage in terms of gigabytes and the key pair, SSH key pair as well. And as for networking, you can go ahead and create a new VPC or you can always use a default one. And this is the IP address to access your application, port address. And when you're launching your application using EC2 types, then you'll have to give two subnets here, subnet 1 and subnet 2. Well, you can go ahead and add more subnets as well. Make sure to mention the IP address and the port range here so that people can access your application. Then you have an instance IAM role. It says that Amazon ECS container makes calls to ECS API actions on your behalf using this IAM role. Well, if you can always go ahead and create one, otherwise ECS will create one for you. So this is how you create a cluster on your own using EC2 Windows option. Now let's select Fargate. Okay, and click on next step. So earlier there were options regarding EC2 instances, type, on-demand, spot, number of instances, all that. But here you don't have all those reasons, just a cluster name and VPC if you want to add it. That's it, and click on create. It's as easy as that. So let's go back and click on this get started option. Okay, so let's say you just have created image. Forget if you've created any task definitions or anything. So using this when you click on this get started option, you can do all the 3 steps which we did earlier in just 1 step. So in the key concepts portion, which we discussed in the theory part, we've learned the container definition, container image, task definition, services as in the Amazon ECS scheduler, which assigns the task to the cluster. Then you have cluster. It's a collection of resources that we assign to your application. So there we go. First, we need to define a container, as in create a container image. You can always go ahead and click on this edit option and configure option and create a container image of your own. But for this demo, we'll be using a sample or preloaded container definition. Well, you have Nginx web server, Tomcat web server, and a simple web app. So I'm going to use this simple app and click on edit. I'm not going to change anything, just to show what is there. So let's retain the same name, simple app. And this is the image ID. And it's chosen soft limit for the memory and 512 bytes. Okay. These are the required details. And make sure that you enable port 80 so that your application can be accessed. And you have advanced container configurations as well, like health checkup, as in the timeout, time in periods. Then you have environment details, the number of CPU units, network settings, storage and log details as well. and many other details among this. Once you've made the changes according to your requirement, you can just go ahead and click on update. But I'm going to use the same details. So let's just click on cancel. Next, you need to configure task definition parameters. So task definition name and the network mode as in VPC, default VPC. You can always go ahead and create a new role, or you can just say use the existing role. So edit. So the task name, network mode, execution role, I've selected ECS task execution role, the default role which ECS assigns to me. Then there's a launch type, obviously it will be Fargate. Then task definition parameters are like task memory unit and task CPU units as well. You can mention that and click on save option. Now, a container image is created, but here we have used the preloaded container image and we have configured the task definition parameters as well. So the next step, we need to define a service. As in, we have created multiple tasks in the previous steps. So all these tasks need to be assigned to a cluster. So this is why you need to define a service so that it knows which Docker image to use, how many containers you need, how many resources are allocated to your containers and all that stuff. So give your service a sample name. Let's just click on this edit. So give your service a sample name and specify the number of tasks. Like I said earlier, these tasks are instance of task definition. So you can create as many tasks as possible out of task definition. Suppose one of your tasks is unhealthy, you can go ahead and use other task instead of this unhealthy task. But for this demo, I'll be using just one task. You can specify here. Then make sure to give IP address and port range should be 80. Remember that. And if you want load balance to be enabled, then you can just click on application load balancer. It says here that if you're not using a load balancer, then a security group is created to allow all public traffic to your port. But if you're using an application load balancer, 2 security groups are created to secure your service. Since we're not using any load balancer, let's say all the traffic will be directed to this port 80 and click on save option. That's it, and click on next here. Now we'll have to define a cluster to hold all these containers as well as the resources which you have assigned to your application. So give your cluster a name, an ID, VPC ID if you're using any, and subnet ID if you're using any. Well, as for this demo, I've selected an option which says automatically create a new one for me. So ECS will handle that for me, and click on next option. Okay, there you go. This is the page where you review all the details which you have given till now, and you can go ahead and make changes if you have done any mistake. So we have selected a sample container, and as for the task definition parameters, okay, the network mode, task execution role, container name, image ID, and task definition parameters as in memory protocol. And as for the service, I just want one task. And as for the cluster name, which is default, by the way, let us change the name. Let's say my first cluster. It should be fine. Okay, next. Okay, it is my first cluster, and VPC and subnets will be automatically assigned by ECS. Then click on create. There you go. It takes a while, but your application will be successfully launched by Fargate for you without you having to bother about any EC2 instances, or you don't have to bother about the containers and all that stuff. Well, wasn't that easy? Just few steps. Using one step, like using one click, we created a container image, we created a task definition, we created a service which handles these containers, and a cluster which holds these containers as well as other resources that your application might need. So all that is happening in the background, but the status is being shown to you here. So it says cluster has been completed, properly created, task definition is also created, service is still being created. And as for the log group, it already exists. And then you have subnet 1 and subnet 2 security groups and the default VPC. So let's wait for a while. Okay. So it says your service has been created properly and you can view your service. Okay, let's click on view service. Okay, there we go. The cluster, my first cluster, it's the name. Status, it says it's active. This is a task definition, default task definition, which Fargate created for us based on the specifications which we provided. And the launch type, obviously Fargate, and it's the latest version of platform that it's using to deploy an application. You have other details as well. As for the load balancer, we haven't enabled it. If we do, then it shows the load balancer is enabled. All the details related to load balancer as well. Okay, then we have network details, VPC and subnet groups. Okay, let's start from the back. Logs. It's still loading. So we haven't done any activity using this. So for now, it's not showing any logs. Same for the metrics as well. For now, the graphs are blank. So if you remember, we just selected one task. It says the health percent is 100, maximum percent is 200. If you have selected 2 more tasks, it would have shown the health of all those tasks here as well. Okay, these are the events, as in the things which we did from the time we created a sample service using Fargate. It just shows the list of activities that has happened. Now, if you want to view your sample web application on your web browser, then you go for this task, click on this task ID. It'll take to your page where it shows the details regarding your cluster, your task definition and all that. In the network details, you have this Elastic Network Interface ID. You click on that, it'll take to EC2 page. There, when you scroll down, you have IPv4 public IP. You copy the address, Control C, and paste it on your web browser and click enter. So there you go, guys. It has created a sample web application just in few steps. Okay, now let's go back to our Elastic Container Service and see if there's anything left to explore. Okay, so this is the cluster we just created, my first cluster. It says one service, one task is running right now, no pending tasks as well. Okay, that's it, guys. Now you know how to launch a container or how to launch your different containers or an application using Fargate launch time. Well, wasn't that easy when compared to using just the Elastic Container Service using EC2? Well, I've done nothing. It's just a small part of what Fargate can do. Go ahead and explore it. Create your own applications, create your own container image, attach it to the task definition, and explore Fargate. So that's it, guys. I hope the session was informative, and thank you.